Hello everyone, welcome to my channel, and today we are at day 2 of solving a bite-sized programming or coding question. So the question is, we are given an array of numbers and an integer k. Our task is to find the average of every contiguous subarray of size k. For example, if the array looks like this and the k is 5, like you have to find your window will be of numbers 5, you need to compute the average for each group of 5 consecutive numbers. From here, if the array looks like this, I have also included a negative number here so that when we run or go through the code, it includes all the use cases. Your average should certainly look like this. Okay. Now we'll go to the solution of this. So this solution uses exactly the same sliding window idea as in the previous video, but the only difference is that instead of tracking the maximum sum, we compute the average for each window. So hope this clears that what is the problem is and what we are trying to do. So here I have created a function find average which takes this parameter which is of an array of number. It takes the window size and returns a number. So in the code, if you have seen, I have added a lot of console log because I'm teaching you here how to do that. And I've tried to write the code as leniently as possible so that each step we are able to visualize how it's happening. So how we'll go, first we'll define our window sum as 0. That's how we did in our previous example also. Then till the number is there not equal to less than, like from 0 to 5 we need to find. So we're starting from 0, so 0 1 2 3 4 total 5, we will get our first window sum. And yeah, so I have put a log for us. When we try to run it, we'll see. And then here the difference is, so here if we see, what we are trying to do is we are pushing the window sum by k. So the average of whatever the initial window sum divided by that number, we are pushing it into result. Now the actual code comes up where a brute force approach would be to calculate the sum of every subarray of size k separately. But that means we would repeatedly add the same element again and again, which is insufficient. So instead of that, we can use the sliding window technique. First, we calculate the sum of first k elements. This represents the first window, which we have done here. Then as the window moves one step forward, we add the new element entering the window. So the right side element we will add, and we will subtract the element which is leaving the window. So left side element we will remove. These two lines can be coded into one line, but as I wanted to show you the logs, I have written in different ways. So this allows us to update the sum efficiently without recalculating everything from scratch. And finally, we divide the sum by k to get the average for each window. Now, let's see. So this is the piece of the code in one screen. Now, once we execute this piece of code, so this is the array and this is the number. How will we get the results? So initial window of sum is 11. If you see 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Till 4. So we will have these numbers till -1 like this. And so initial result will be at 2.2 because we are dividing by 5. Now window sum. So we were at 11 and number right now window has started to shift. 4 number has come. And so what will be the now next window sum here? If you see here, we were at what, 11 and the number was 4. So it did the plus here and the window sum became 15th. But now we have still, now if you see window size has grown, right? We were supposed to have only 5 numbers, we have more. So we have to shift the window. So if we shift the window, we reach the 4 and we have to subtract the 1 from here. because right now 1, 2, 3, 4, 5, 6 numbers we have window size of 5, so we're subtracting 1 and we reach here at the 40. So this is the window sum with right minus k 1. So we have this. So this is how it will continue. If you see here correctly, when we have 14 and then we add 1 to it, we became 15, this one. Then we realize, oh, 3 we have to move out, we become 12. Then the next number is 8, we add, we become 20. Okay, so still it's like this. Then we remove 2, we become 18. So like this continues and all. And we get, now you have the five contiguous subarray averages, and then this is how your sum goes. So in this, one more thing, it's just not about how we are creating, we are pushing the window sum divided by k as soon as we are getting this is not like outside of the loop we are finally getting that max sum. So this is the difference in the logic, and take it as a 1 plus programming question when you're preparing for this pattern of sliding window. So thank you for watching the video, and if you like the channel, to subscribe.